You are welcome to my channel. I'm so delighted to meet us again. In my today's class, we'll be doing ratio and proportion. That's the discussion for today. Okay, ratio and proportion. So by the time I'm through, I believe you will know what ratio is and what proportion is and the relationship between the two. So sit back and let's do this together. Hope you have your pen and paper there. You must write something. It's very important. It's necessary that you practice these things with me. All right, let's go. So I'm starting with ratios. Ratios are comparisons made between two sets of numbers. My two sets of numbers here are A and B. A and B. I have A and B. They are my two sets of numbers. I have A and B. A column B. That's how you write your ratio. That's the format. Or you have it as A over B. A over B. So A here is my first term and it's called antecedent. Okay. And B is the second term and it's called consequence. Okay, so we'll be going through this, and by the time we are done, you will know what ratio is all about. So in our next, we'll look at an example now. Okay, I have a basket containing 8 apples and 15 oranges. 8 apples and 15 oranges. Now the question is, what is the ratio of apples to oranges? What is the ratio of apples to oranges? And this is what we have. So we have apple and orange in the basket. So they are the two sets of fruits. Okay. And then we are looking at the ratio of apples to oranges. So it's going to be the number of apples to the number of oranges. So we have 8 to 15. 8 to 15. Okay, let me get my writing material. So this is it. 8 to 15. That is the ratio of apple to orange. Okay, 8 to 15. 8 is for the apple. Okay, that's the number of apples we have here. 15 is for the oranges. That is the number of oranges we have here. Is that clear? Drop your question in the comment box if you have any question with regards to this. Okay? Alright. So 8 is the antecedent, that is for the first term. Okay, 15 is the consequence, that is for the second term, 15. Okay, alright. So next, we are going to look at 3 ways you can write your ratio. 3 ways you can write your ratio. Number 1, you can write the ratio using the word 2 between the two numbers being compared. Okay, you can use the word 2. Let me underline that. You can use the word 2. Okay, alright, you can use the word 2. I'm highlighting it. Okay, you can use the word 2. Okay, to show the ratio. Okay, and the toe should be between the two numbers you are comparing. So for instance, we have there are 8 girls and 7 boys in the class. So we are looking at the ratio of the girls to the boys. Okay, the ratio of the girls to the boys. And here is what I have. The ratio is 8 girls to 7 boys. So we have the number of the girls to be 8 to 7, which is the number of the boys. So here I use 2. I use 2. Okay, 8 to 7. 8 to 7. 8 to 7. And the girls to boys is what we are looking. So the number of girls comes first, and then that of the boys is the second. Is that clear? So another way you can write your ratio is using a column. Using column. You can use column. Okay, let me also show how you can do that. So this is your column. What color should I use now? Okay, let me use this. Okay, this is your column. And it's going to be between the two numbers being compared to. Between the two numbers being compared. Alright. So we have an example. There are 8 apples and 7 oranges in the basket. What is the ratio of apple to orange? Okay. So we have 8 apples to 7 oranges. And here we use the column to represent our ratio. Okay. So here I have 8 column 7. 8 column 7. 8 column 7. So I'm highlighting it. 8 column 7. The column is in between 8 and 7. That is the antecedent and the consequence. Okay. So that is using column to represent, to show, your ratio. Okay. Next we can use fraction. We can use fraction, and here is how you use fraction. So there are 8 girls and 7 boys in the class. What is the ratio of boys to girls? Okay, our antecedent here will be the number of boys, and the consequence will be the number of girls. Okay, so you can see the fraction is 7 for the boys over 8 for girls. Okay, so let me also get this. Okay, what color should I use? Let me use red. Okay, so I'm having it shades just to highlight it. Okay, so I have 7 over 8. 7 over 8. Is that clear? So that is when you want to use a fraction. When you want to use fraction. That is how you use your fraction. So let me clean up this down. Sorry for that. And then use paint just on the line. Alright. So that is it. So go to our next slide. So we still have another example. There are 13 boys and 17 girls in a party. Okay, what is the ratio of boys to girls? And now I want you to use the 3 different ways, 3 different methods. Okay, I've just explained to show me the ratio of boys to girls in this party. Alright? Alright, so using 2, we have 13 boys to 17 girls. Remember, you write only the numbers. Okay, so I have 13 to 17. 13 to 17. That is using 2. And using column, I have 13 column 17. 13 column 17. That's the second way. And the third way is fraction. I guess you know that one. 13 over 17. Isn't it easy? Isn't it very simple? So this is how you can use the 3 ways to column fraction to represent your ratio. Okay, try it over and over and over. Drop a question if you have one in the comment box below. So next we have reducing ratio. Reducing ratio. Ratio can be reduced without changing their relationship. The relationship still remains the same. We can reduce it to the minimum. and in fact all ratios must be reduced to its lowest term. Must to their lowest term. You must reduce them. You must. It is a must. Always reduce your ratio to the minimal term. Okay. So here is an example on how you do that. Good. So you score 40 answers out of 45 questions on a test. Okay, you scored 40 answers out of 45 questions on a test. What is the ratio of your correct answers to your wrong answers? Now here we don't know the number of your wrong answers, but we can figure that out. Okay, so what we do is first of all find known is the correct answers, which is 40. So we can find the wrong answer by subtracting 40 from the total number of questions you have, which is 45, and that gives us 5. I hope that is clear. Let me show you what I'm saying. So we know the right questions. The correct ones you answered are 40. Then the wrong ones we are not told, but we can figure that out by taking out the right ones from the total number of questions you have, and that gave us 5. Now the question says we should find the ratio of the correct answers to the wrong answers. So this is it. The ratio of correct answers to wrong answers. So what is the number of the correct answers? We have 40. What is the wrong answer? We have 5. So that would be 40 over 5. Now we can simplify this further. We can reduce, like I said, you must reduce if they can be. So we find out what should be the lowest. We divide by 5. If I divide by 5 now, we get my pen. 5 to itself will give me 1. 5 to 40 will give me 8. I don't think any other thing can divide, so we have them in their lowest term here. So having that, I can now say, okay, 8 over 1. 8 over 1. That is in fractional form. But I prefer putting it in column form, so I have it this way. 8 column 1. 8 column 1. So always reduce your ratio to the lowest term, to the minimum. Okay? So, and this is how you do that. Thank you. So we go to proportion. Proportions are two ratios of equal value. You have two ratios and they have equal value. So you get them together, it becomes a proportion. Okay, the two being equated together, you have proportion. So here is an instance. A proportion can be written in two ways. You can have them using columns, and then this is A, column B, column C, column D. I prefer the fractional part where you have A over B equals, this column here is simply equals, okay, equals C over D. Alright, so here is my example here. We are looking at 3 cans of soup cost $5. How much will 12 cans cost? Okay, so I'm looking at my solution. I'm taking the ratio as the number of cans to the cost. Okay, number of cans to the cost. So the first information given is that 3 cans would cost $5, and that is why I'm having 3 over 5 here. Let me get my pen. That is why I'm having 3 over 5 here. So it's equal sign. So this is the number of cans. Let me circle it. and this is the cost for the number of 3 cans. Now the question demands for 12 cans, and I have it here, but I don't know the cost, so I need to figure that out. Now what I did is I asked myself, what should I multiply 3 by to get 12? And I figured that is 4. Now I'll now do it for both that of number of cans and the cost. So both becomes 12 over 20. So for 12 cans, I'm having $20. Okay, for 12 cans, I'm having $20. So 12 cans gives me 20. I will buy 12 cans for $20. Is that clear? Good. So we'll go to types of proportion. Types of proportion. We have direct proportion and we have inverse proportion. Direct proportion, inverse proportion. Alright. So for direct proportion, this is how the graph looks like. If it's going up, you have it up, up. If it's coming down, you have it down, down. Let me highlight or this pointer. So I have it this way. Okay. Let's say here is okay, let me get pen. Let's say here is speed. Speed. So this graph is speed. Speed against distance. Speed against distance. Sorry. Okay. Speed against distance covered. Distance covered. That's what the graph is all about. So the more the speed, the more the distance covered. The less the speed, the less the distance covered. Let's see. Oh yeah. So the more the speed, the more the distance covered. The less the speed, the less the distance covered, and so on. Sorry, to get cleaner. Yes. See. So let's go to the details. So for direct proportion, two quantities are directly proportional if one increases and the other quantity also increases. If one increases and the other quantity also increases, or vice versa. If one decreases and the other quantity also decreases. Now I use an example of the speed of a car and the distance covered like I have here in the graph. So the more the speed, the more distance covered. The more the speed, the more distance covered. So we have, this is a sign of proportionality. Right? These are our sign of proportionality. So speed is directly proportional to the distance covered. So that's what I have here. Speed is directly proportional to the distance covered. Directly. Increase in one will also cause increase in the other. Decrease in one also cause decrease in the other. So That is what direct proportionality is all about. Okay. Now here is an example. We have JC covering 4 miles in 30 minutes. At the same rate, how far would she run in 45 minutes? How many miles will she cover in 45 minutes? And this tells us that she's going to cover more, okay, if it is at the same rate, at the same speed, okay. So we have, okay, let the unknown be x, so it means that we are taking this as, you get my pen, so we have it as miles over time. Take it. Miles over time taken. Sorry, I'm taking the time. All good. Alright. So for the first information, 4 miles is 30 minutes. So we don't know for now the miles that will give us 45 minutes. Now I wanted to think, what should I multiply 30 by to get 45? And just trying to make me, I should know. Okay, let me not waste my time thinking about that. Let me cross multiply. Okay, so sometimes you will not get a straightforward answer by thinking of what should I multiply this by, like we did previously. It may take you time. So the best thing to do is just to cross multiply. So if I cross multiply 30 to x, which is what I have here, and then 4 to 45, which is what I have here. Okay, now I can simplify further, and if I do that, I'll have a 30x, okay, equals 1/8 equals 1/8. Okay, and then I can divide both sides by 30. I don't know, do I have the space? Yeah, I can divide both sides by 30 and having my x now below. Okay, divide by 30. 0 cancel 0 here. 3 to itself is 1. 3 to 18 is 6. Meaning that it's she covered 6 miles in 45 minutes. Let's see. Okay, so I'm having it 6. So she can run 6 miles in 45 minutes. So that is it. Okay, so the more speed, the more miles covered. Okay, so we have this. Now, in an election, David got 3 votes for each 2 votes that Steve got. So that means if 3 people voted for David, 2 voted for Steve. I don't know whether you're with me. If 3 people voted for David, 2 voted for Steve. Now at the end we have 72 votes for David. So can we tell the number of votes we have for Steve? How many votes did Steve get? So let's see. So you can see for David, we are taking the ratio David to Steve. So we have 3 to 2. 3 to 2. Let me get my pen. So for David, 3 votes count 2 for Steve. So if the total is 72, I will select the one for Steve, which we don't know, the n. Now I can cross multiply like I did previously, but I think here I figured out a number that I can multiply 3 by to get 72, and I have it as 24. So I did multiply both 3 and 2 by 24, and I have my 72 and 48. That is to say that Steve got 48 votes. Steve got 48 votes. Okay, so we'll proceed. Inverse proportion. Inverse proportion. This is how the graph is. This is how the graph is. Okay, so inverse proportion describes the indirect relationship between two quantities. Indirect relationship in the sense that if one quantity increases, the other decreases. The relationship is not direct, it is indirect. Increase in one brings about decrease in the other. Decrease in one brings about increase in other. So we have the sign of proportionality, and this is how inverse proportionality is represented. So I'm having y. Okay, this is the sign of proportionality, and then you will have it as 1 over x, because increase in y will cause decrease in x. Okay, so example is increase in the speed of the car. Increase in the speed of a car will result in covering a fixed distance in less time. So the more the increase, the more the speed, the more the speed, the less time it takes to cover a certain distance. The more the speed, the less time it takes to cover a certain distance. Okay, so we have an example. It takes 4 men 10 days to complete a job. How many days will it take 20 men to complete the same job? Think about it. 4 men, 10 days. 20 men, that would be less days. Okay, less days. So this is how you handle it. The more men employed, the less time it takes to complete the same task. It's obvious. It's obvious. So how do we calculate it now? 4 men complete a job in 10 days. Let's say 1 man. How many days will it take a man to complete this work? Okay, so duration taken by 1 man is just 4 times the 10 days. Okay, giving us 40 days. It takes a man 40 days to cover this same job. And for us to get for 20 men, what we do is we divide by 20, and that gives us 2 days. So divide 40 days by 20 men, and we have 2 days. So it takes 20 men 2 days to complete the same job. Is that clear? So proceed. 9 taps can fill a tank in 4 hours. 9 taps can fill a tank in 4 hours. How long will it take 12? That is increase now. That's how long will it take 12 taps of similar flow rate, okay, to fill the same tank? Okay, will it be more or less? Definitely it will be less because we have more taps now. So let's see. So for 9 taps we have 4 hours. 4 hours. So let's see. Okay, for one tap, what will it be? 9 times 4, and that should be 36. 36. Okay, so let me write it. So for one tap, it will take 36 hours. 36 hours for one tap. That's a day plus. A day plus. Okay. So let's see for 12 taps. So all I need to do is to divide 36 by 12. So if I do that, I will have 3 hours. So more taps, less hours. Okay. So that is inverse proportionality. Inverse proportion. When you have more taps, it takes less hours to complete the task. Okay. So proceed. Alright, this is where we'll start for today. I want you to try these exercises again and again. Drop your question in the comment box. Like and subscribe to my channel. Thank you and see you next time. Thank you.